Hello dear viewers, welcome to TV Mathshub. This is your study pattern for competitive exams. Here you will find different questions, clear solutions, and the guidance you need to succeed. Subscribing is completely free. It is just your way of appreciating our work and supporting the channel. So don't forget to hit the subscribe button and let's learn together. Hello dear viewers, welcome to TV Mathshub. In our today's session, I will be taking you through one of the most important and commonly asked questions, that is about curve sketching. So today we shall be concentrating majorly on how best we can master curve sketching for advanced rational functions. At the moment, majority of you must have already learned about sketching curves of this nature. But in our today's session, we want to look at how best we can now sketch curves where you have f of x over g of x instead of only having f of x. So these are what we call the rational curves. So how do we sketch such curves is basically what we shall be looking at in our today's session. So for those that are preparing for their final examinations, please consider subscribing to this channel. We shall be bringing to you some of the most commonly asked questions and how best you can attempt them. So far, this is one of the best videos that you need to look at before you sit for your examinations. Having already the 12 marks already pocketed is very important. It means you will now be looking for other marks from other sections. So let us move together and make sure you master curve sketching. We shall do only 2 examples. We shall look at examples where we shall have to talk about some few different things. So make sure you watch the 2 videos fully. That will help you in your preparations for your final examinations. So in our today's session, we shall look at one of the examples, and in our next video, we shall talk about another example. So make sure you check through all our 2 videos. Make sure you see the difference between the questions that we shall be handling and how best now you can use the same knowledge in attempting any question that will be about curve sketching, especially for rational functions. So before we come to examples of such curves, we shall first of all look at some of the basic principles that you need in order to sketch such curves. So let us talk about some of the principles that you need to sketch such curves. So we shall look at the basic principles. We shall look at the basic principles. Basic principles that we shall be following when we are sketching rational curves. So basic principles followed when sketching rational curves. And rational curves, we have said these are curves of the nature f of x over g of x. So that is basically what we shall be handling. So basically, what are some of the things do we need to know to sketch such curves? So the first one that we shall always be looking at is finding the intercepts. So we need to first of all find the intercepts. And finding the intercepts calls for only 2 things. One is to look at the y-intercept, and 2 is to look at the x-intercept. And we shall be saying that for x-intercept, y is 0, and for y-intercept, x is 0. So basically, those are the 2 things we shall look at when we are finding the intercepts. So we shall look at finding the turning points, finding the turning points. And finding the turning points, you will first of all get the turning points, and we know at the turning point the y dx is equal to 0. And at the same time, after looking at the turning points, you need not to forget, you need to talk about the nature of the turning points. So you need to talk about the nature of the turning points. So the nature of the turning points: are the turning points maximum, are they minimum, or it is a point of inflection? So you need to look at all that. So next you need to talk about finding the asymptotes. Finding asymptotes. On finding the asymptotes, we have got three kinds of asymptotes. The first one is what we call the vertical asymptotes. So that is vertical asymptotes. And for vertical asymptotes, these are normally obtained by equating the denominator. You equate the denominator to 0. So these are the values of x for which y tends to infinity. So if you are having your y as f of x over g of x, for what values of x will make this function undefined, or will make y to tend to infinity. So that is when g of x is equal to 0. So here you equate the denominator to 0. And the values for x that you will obtain will be the values that will be called the vertical asymptotes. And next we talk about horizontal asymptotes. Horizontal asymptotes are the values of y. These are the values of y which makes x to tend to infinity. So values of y which makes x to tend to infinity. In most cases, we obtain these by dividing. So we obtain these asymptotes by dividing terms on the numerator and the denominator. Terms on the numerator and the denominator by the highest power of x. By the highest power of x. By the highest power of x. However, to know that a given curve has got such asymptotes, one, in most cases you look at the degree of x. So the degree of x in the numerator and the degree of x in the denominator. So you look at the degree of x here. So for example, if you have the highest power of x here as x squared and the highest power of x here as x squared, then such a function will be having what we call the horizontal asymptotes. Also, if you have, for example, x here and here in the denominator, the highest power of x is x squared. So also such a function will also have a horizontal asymptote. In other words, the degree of x in the numerator must be less or equal to the degree of x in the denominator. Must be less or equal. Meaning if they are equal, you expect to have the horizontal asymptote. If it is also less, you expect to also have the horizontal asymptote. Then the next, and that is the last kind of asymptote that we shall talk about, will be what we call the slanting asymptotes. Slanting asymptotes. And for these slanting asymptotes, we shall obtain these, or they occur only when the horizontal asymptote does not exist. So if you are not having the horizontal asymptote, then you will have what we call the slanting asymptote. And under which case can we have no horizontal asymptotes existing? As we have seen, if the degree of x is less or equal, if the degree of x in the numerator is less or equal to the degree of x in the denominator, then we shall have the horizontal asymptote. However, if the degree of x here is greater than the degree of x in the denominator, then you will have what we call the slanting asymptote. Meaning the slanting asymptotes exist when the power of x in the numerator is greater than the power of x in the denominator. For example, in the numerator you can have an expression like x cubed minus 1. In the numerator and the denominator you have like x squared plus 2x plus something. So you realize that the highest power or the degree of x here is greater than the degree of x in the denominator. So in this case you expect to have what we call the slanting asymptote. So you must distinguish on which circumstances will I have the horizontal asymptotes and when will I have the slanting asymptotes. Otherwise you cannot have the two at once. You cannot have the two at once. So that is about getting the slanting asymptote. So how do we then get the slanting asymptote? After realizing that our given function consists of a slanting asymptote, that is after noting that the highest power of x in the numerator is greater than the highest power of x in the denominator, we expect to have a slanting asymptote. But then how will we get the slanting asymptote? We obtain the slanting asymptote. Since this is an improper fraction, we shall obtain the slanting asymptote by simply dividing this with this using wrong division. So you use wrong division, divide this one with this, And what you obtain as your quotient here is what you will be referring to as the slanting asymptote. Because when you use this, of course, you will expect to have this divided. So you are having like x cubed minus 1, you are dividing it by x squared plus 2x plus c, for example 1. So when you divide this, what will be your quotient here is what we call the slanting asymptote. So the slanting asymptote will be the quotient that you will obtain after the wrong division. So that is how we obtain that. And that will be y. So y will be equal to the quotient. The quotient you obtain becomes the slanting asymptote. So that is how we get the asymptotes. So in most cases, which are basically, if you are dealing with rational curves, you expect to have the vertical asymptotes. That is when we equate this one to 0. Then to look at the horizontal asymptote and the slanting asymptote, then you look at the degree of your x in the numerator and the denominator. That will give you the impression of what you expect. So do you expect the horizontal asymptote? That is when the degree of x is less or equal to the degree of x in the denominator. So if the degree of x in the numerator is greater than the degree of x in the denominator, then you expect to have the slanting asymptotes. Then you divide the two, what you obtain as your quotient becomes your slanting asymptote. So basically that is how we obtain the asymptotes. So basically we have seen we need that, we need this, we need that. So having gotten the intercepts, the turning points, the asymptotes, then we shall look at the next. So you also need, the next thing that you will need to talk about is now investigating. So you need to find the regions where the curve exists and the regions where the curve does not exist. So the next would be finding or investigating the regions, finding the regions where the curve exists, where the curve exists, where the curve exists. And we find such regions, by considering what we shall be calling the critical points. So we get the critical points, or the that is the range for x. So you are looking at the range for x here. So that is the range of x where the curve exists. And we obtain that by simply equating each of these terms to 0. That is the numerator to 0 and the denominator to 0. Then you get the values of x, and those are the values that we shall be calling the critical points. So these are points we shall use to find the regions where the curve exists. And lastly, we shall be finding the region, that is finding the region or regions where the curve does not exist, where the curve does not exist, where the curve does not exist. So how do we obtain such regions where the curve does not exist? So that one will be obtained by forming a quadratic equation that will be in terms of x. Then you put for the real values of x, for which b squared minus 4ac is greater than 0. Then you solve this, and this will be giving you the range of y. So this, you will be talking about the range of y. And here you will be talking about the range of x. So here you will be talking about the range of y, here you will be talking about the range of x. So that is how, or that these are some of the principles that we follow when we are sketching such graphs. So we shall look at examples, and these different examples majorly will be different, and the difference will be coming from the asymptotes. So especially, so when you are looking at the asymptotes, we need to know under which circumstances we shall have horizontal asymptotes and under which circumstances we shall have slanting asymptotes. So some of the two examples we shall look at will be the examples where there is a difference, especially in the asymptotes. So you don't need to miss each of these videos. Make sure you check out all of our videos about curve sketching, such that you master the concept of curve sketching, and you will translate the same into different questions. So that is basically some of the procedures that we follow. And the next thing is now to look at some of the examples, of how we can obtain all this that we have talked about.
Yeah.